Let's continue our discussion of the solid principles. Today, we'll close out this series by looking at the D in solid, the dependency inversion principle. This can be expressed in two steps. First, high-level modules should not depend on low-level modules. Both should depend on abstractions. And second, abstractions should not depend on details. Details should depend on abstractions. So, we get the references to dependencies, this depends on that, but where does the inversion come from? Let's illustrate. Back in the first part of this series, I gave an example of my binary tree painting code. In essence, given a binary tree, this code would paint a visible representation of the tree so that we could look at it and understand properties of the tree. This node is a child of this one, and so on and so forth. My original code failed the single responsibility principle. Navigation code and drawing code were intermixed, but also failed the open-close principle. The code only worked for one type of graphics context, and I couldn't extend the behavior without altering the code. Let's take another look at that last one. In essence, the code that drew each node or edge was dependent on one particular graphics context, the normal drawing code in .NET. My high-level paint this node code depended on the low-level details of how painting was implemented in system.drawing. I indicated at the time that the solution was to abstract out the painting into some idealized interface to a graphics context. Set one up, draw a line, draw a filled circle, etc. What we're doing is inverting the dependency. Instead of depending on a concrete implementation, I should be depending on an interface. Then, using the Liskov substitution principle, I could write an implementation of that interface that would stand in perfectly for the interface itself. The two modules, high-level tree painting and low-level drawing, a node, no longer need to know about each other. Instead, they communicate through an abstraction. Once we have such a dependency inversion, we're on a roll. We can test classes independently of each other. We can mock or fake interfaces for the intent of testing the class in question. Classes we write don't have to depend on setting up a huge database, for example. We can fake the abstraction. Or even better, we can set up factories to produce concrete behavior at runtime driven by configuration files. We can use injection frameworks to provide data and behavior to applications that had no idea such data or behavior existed. Ninject, Spring.NET, Castle Windsor, and so on, here we come. Of all the principles in Solid, I feel the dependency inversion principle is possibly the most important and also possibly the hardest to convince someone to adhere to. But oh, the benefits if you do so.